Okay, see this question. It's an NET question from fluid mechanics chapter, fluid mechanics subject. 2 meter into 1 meter tank of 6 meter height is provided with a 100 diameter orifice. So 2 meter into 1.5 meter tank with a height of 6 meter. Okay. So 2 meter into 1.5 meter is the basically the cross section area. Okay, 100 diameter at the orifice at the center of its base. The orifice is plugged and the tank is filled up to 5 meter. Okay, consider the average value of discharge coefficient, that is 0.6, and the acceleration due to gravity g as 10 meter per second square. After unplugging the orifice, the time taken for the water level to drop from 5 meter to 3.5 meter. Okay, under the free discharge condition, round off to two decimal places. So I have drawn a tank. Height of this tank is 6 meter, which is mentioned to you here. It's a 6 meter height. Okay, total height is 6 meter now, which is mentioned to you. Water level drops. So this total height, let us say this is 5 meter only. So total height of depth of water they have given 5. So from 5 to 3.5, this much change which is occurring na, this much change which is occurring. So basically what you do, you find out for a small change first of all. Let us say for a small delta H change. This is the orifice through the discharge is coming out. So I'm writing it for a small change in height. I'm not considering right now from 5 to 3.5. I'm just considering delta H, small change. So for a small change, I can write it in this way. For small change in depth, for a small change in depth. So it will be A naught into DH. Sorry, A naught into velocity here actually. So total volume of water which is going out will be A naught of area of the total. So that I can write it as A into DH. Into DH. This is the total area which comes out. This is the total area which comes out. Now this area which is going out from the orifice. So orifice is basically area into velocity. Area of orifice will be A naught. I can write it into velocity will be nothing but CV root under 2GH. Root under 2GH. Currently, putting 5 is also not required. Everything I am taking in a general. Everything I am taking in a general. So this H is basically the H part. Okay. Now this will be equal. See, small change, whatever change in depth happened, from that whatever volume which went down, through orifice only it will pass. Through orifice only it will pass. So both sides will be same, na? Both sides will be same. I'm interested to calculate. Acha, one thing more. This is the volume. This is the volume. Area into height. This is the volume. Area into velocity here. Area into velocity here. So area into velocity, this will give you what? It will give you discharge. You need to multiply with time also. So time also I am writing it dt. So if I want to write dt, let us say if I want to write dt, it will be A upon A naught into CV root 2g. Very good. In bracket dh upon root under h. I don't think so anybody will have any issue here. So for a small change dh, we calculated the small time, like small change in time, that is a small time taken, that is dt. Now if I want the total time, what I need to do? I need to integrate it. So integration of dt will be equal to integration of this part actually. So those things which are constant, A upon A naught CV root under 2g, these are constant. So basically integration is dh upon root under h, and limit will be h1 to h2. Yes or no? Yes or no to all of you? Okay. Now things which we can write it down, like data basically we are putting it. So T equal to H1, that means from 5 to 3.5 na change, we are 5 to 3.5. 5 to 3.5. This much change is occurring na. This much change is occurring from H1 to H2. So up to this, I think everyone is clear. Up to this, I think everyone is clear. One second. As you are going downward, na, as the H is going downward, so you need to put minus sign. But if you don't want to put it the minus sign, you have to actually write in a reverse way. I hope you got it. I'm explain it again. So basically what I'm telling you, this will be the H2, this will be the H1. Why I'm saying it? If you don't want to write it, you have to put minus sign. So it's a decreasement, now you have to show that decreasement. If I will write like this, na 3.5 here, 5 here, the value will come negative. Time will never be negative, na. So it is 5, 3.5. I hope you got it. Now integration of root under H, it will be nothing but h to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. Okay. Limit will be 3.55 into this area. This area will be nothing but 2 into 1.5 tank area, na? So 2 into 1.5 divided by pi by 4. A naught will be the orifice area. Orifice area will be the pi by 4, 100 mm 0.1 whole square. Pi by 4, 0.1 whole square into root under 2g. So g they have given 10. G they have given 10. So root under 2g and the CD they have given 0.6. So 2 into 10 into 0.6 into 0.6. So I think all the things I have written for all of you. Now it's a matter of calculation only. It's a matter of calculation only, which you all can do it as quickly as possible. I want everyone to do it fast. So T equal to minus 1 by 2 plus 1, basically 1 by 2 only. It will go on the top. It will become 4 1.5 divided by pi by 4 0 1 point whole square 0.6 root under 20 into this one will be nothing but s to the power 1 by 2 na. So 5 to the power 1 by 2 minus 3.5 to the power 1 by 2 in a bracket. So all those things are clear now. It's a now calculation which you all can do it. According to my calculation, what I'm getting around 103.98 seconds. One not 3.98 seconds. So I can fill it 103.98 second. 103.98 second. So I think it's crystal clear for all of you. I think ये बातें सब लोगों को समझ में आ गई होंगी. 103.98 second, and that will be the up to 2 decimal places they are talking about. So we have given value also in up to 2 decimal places. I hope it is clear for all of you.